So students, yesterday we were discussing about image sensor. Okay, and we have studied that image sensor is a sensor that detects and conveys information which is used to make an image. Okay, and this is done by converting the variable intensities of light waves as they pass through or reflect off the objects into electrical signal. Okay, so yeah, this is what image sensor is, and we have seen that there are a number of applications of image sensors, and we are going to study two types of image sensors because these two types of image sensors are used widely nowadays. One is CCD, that is charged coupled device, and another is CMOS, that is complementary metal oxide semiconductor image sensor. Okay, so basically there is a difference in how the charge is transferred out of the pixel. Okay, so how the charge is read out. So basically charge formation is same in both cases, but only difference in the charge readout or charge reading in case of CCD and CMOS. Okay, so yesterday we are discussing charge coupled devices or CCD. It was invented in 1969 at Well Laboratories. Okay, so earlier it was a dominant technology for capturing images. Okay, so starting from simple applications to the sophisticated applications like digital astrophotography or machine vision. So these are sophisticated applications. So for these, the charge coupled devices were used as sensor. Now, here you can see construction of a pixel of charge coupled device or image sensor. It is made up of semiconducting device and generally of silicon. Okay, and over this silicon insulator layer of SiO2 silicon dioxide is formed, and again it is coated with the metal contacts, and the surface of this pixel is made transparent so that light can fall on it. Okay, so what happens when light falls with energy equal to h into nu? Energy E is given by h into nu. Energy of radiation E is given by h into nu. Okay, and here h is a Planck's constant, which is a constant, and nu is the frequency of the radiation. Frequency of the radiation, and all of us know this nu is given by c upon lambda. Frequency is given by c upon lambda, where lambda is the wavelength of the radiation. So in case of semiconducting device, as we have seen, two bands come in picture as far as its conductivity is concerned: valence band and conduction band, separated by energy band gap of the order of 1 electron volt. Okay, so if this is the case of semiconductor, and suppose when light falls on this, what happens? Photons are incident on the semiconductor, and they are having energy equal to h into nu. Okay, so this energy value should be at least equal to or greater than this band gap value. Okay, that means the wavelength of this radiation must be such that uh, it will be equal to or less than this band gap value. Okay, so if this condition is satisfied, then photons which are present in radiation, they will be imparting energy to the electrons which are present in the valence band. The electrons in valence band, they will get energy and they will be elevated to conduction band. Okay. So now, like this, electrons are formed where the light is incident. Okay, and the number of electrons jumping to the conduction band, they depend on the intensity of light, because number of photons will change with respect to intensity of light. More the intensity, more the photons, and more electrons are freed into conduction band. Okay. So depending on intensity of light, the number of electrons will be released to the conduction band. Okay. So in any image, when light reflects off this image, different intensity of light will be produced. Varied intensity of light will be produced, and this will be incident on image sensor. Okay, so different areas of image sensor, they will be experiencing different light intensities, and accordingly it is generating different amount of charges over its surface. Okay, so in this way the sensor or CCD device is converting image into charge. Okay, and this imaging device has sensitive elements called as pixels, and generally this image sensor is a matrix arrangement of these pixels. So hundreds of these pixels are arranged in rows and columns, and it will act as image sensor. Okay. So photons incident on this surface will going to generate the charge, and this charge can be read by the electronics which is connected to this image sensor. Okay, so this is what is happening in the charge coupled device as well as in CMOS also. Okay, so here you can observe the light is falling on the device, and you can observe three metal contacts are given. 3 or 4 metal contacts will be there on each pixel, and these metal contacts are uh, taking part in charge generation as well as in charge transportation. Okay, so these are responsible for charge transportation from one pixel to another, and then to the finally to output. Okay, so this is what is happening in charge coupled device. So let us discuss the various steps which are involved in formation of image. So step number one is that when light is incident on CCD device by uh, what is called as photoelectric effect. You have studied photoelectric effect, and just now I have explained you. So due to this photoelectric effect, the electrons are liberated. Okay, so this is what is the step one of image formation. Now, in step two, what happens? Number of pixels are present. Pixels are nothing but metal gates. They are present on the surface of the image sensor, and they collect the charges. They collect the charges because as electrons are generated, positive charges will be induced on the metal gate. Okay, and positive charges induced will be proportional to the number of electrons generated. So the charge is generated or collected on the metal pixel. So this is step number two. Now During step number 3, the charge generated by photons is forced to move one step at a time, okay, through application of voltage pulses on electrodes. So as I have shown you, one pixel consists of 3 to 4 electrodes, and to these electrodes we can apply differential voltage, and this differential voltage will allow to move the charge from one pixel to another. So here you can see the row and column arrangement of the matrix. So here you can observe the columns which are present in row number 1. They will be transferring their charge or they will be shifting their charge to the shift register here. This horizontal shift register. This is a horizontal shift register and this is a vertical shift register. So once this charge is shifted here, the charge which is present at second row will be shifted to the first row. The charge which is present at third row will be shifted to the second row. So like this, the whole information goes on shifting one by one and it will be given to horizontal shift register, and through horizontal shift register it will be outputted to amplifier as well as analog to digital converter to convert it into equivalent digital value. Okay, so uh, in step number 3, the charge generated by photon, they are forced to move one step at a time by application of voltage pulses on the electrodes which are present on the pixel. Okay. So step number 4 is sequential readout is carried out column after column through vertical and horizontal shift register. Just now, as I have told you, all the pixels from row number 1, they will be shifted to the horizontal shift register. Similarly, row number 2 will be shifted to 1, 3 will be shifted to 2, like this. The shifting of the charge will be carried out, and after that, shifting of the charge, when the charge is present in the horizontal resistor, the charge which is present in the horizontal resistor is immediately converted into a digital signal by means of analog to digital converter. So this analog to digital converter may be a part of camera or it may not be part of camera. Afterwards, it will be converted into digital in some cases. Okay, but mostly on chip it is converted into its equivalent digital value. Okay, so sometimes amplifiers are also present because the charge is not sufficient. To make it sufficient, the amplifier is used. So between analog to digital converter and horizontal shift resistor, that is at this location there may be amplifier here. Here. Okay, so these are the steps in which the CCD image sensor works. Okay, now let us discuss advantages and disadvantages of CCD sensor. The most important advantage of the CCD image sensor is that it has higher sensitivity, okay, and lower noise. So this is the advantage of CCD sensor. Okay, and defective pixels are also less in CCD device. Its structure is simple, and we get better homogeneity. Okay, image homogeneity. Image must be homogeneous, and that is provided in CCD sensor. So higher sensitivity, less defects, simple structure, and better homogeneity. These are the advantages of CCD sensor. Now, disadvantages, it comes with certain disadvantages, like as charge need to be shifted one by one, and it need to be read and converted into digital value. So this is done step by step, and therefore such type or such method of readout is slow. Okay, and hence the speed of the CCD sensor is limited. That means you cannot use it for high frequency application. Okay. So this is a disadvantage. So second disadvantage is again similar. Readout is serially. Okay. Uh, More complex camera layout due to additional electronic circuitry required. Okay. And the most important thing is that its energy consumption is high. Okay, which is not desired. And as charge moves from one pixel to another pixel, this moving of the charge contributes to smearing or a blooming effect. ओके. म्हणजे तो चार्ज एका ठिकाणाहून दुसऱ्या ठिकाणी जात असेल तिथं स्मिअर दिसून येतं. ओके. सो दिस इज अ डिसएडवांटेज ऑफ CCD sensor. Okay. Now let us go to second type of image sensor, which is complementary metal oxide semiconductor sensor. Okay. So CCD device is also called as passive pixel sensor, but this CMOS image sensor is called as active pixel sensor. Okay. So these are used in many consumer devices. Now, typically CMOS sensor is an integrated circuit, just like CCD, with an array of pixel sensors. Each pixel is a sensor. Okay. So each pixel has its own light sensor and an active amplifier. So this is a difference between CCD and this CMOS sensor, because here each pixel consists of its own sensor and active amplifier. Okay, and an analog to digital converter and other components which are used to locate the charge which is formed on the sensor. So here you can observe different components of CMOS sensor. So here you can observe uh, earlier there is a lens. Through this lens, the light will be focused onto a pixel or onto a color filter. So before pixel array, there is a color filter. After that, there is a pixel array. Then output of this pixel array is given to analog to digital converter. Okay, so it has output circuit board. So this digital signal is connected to output circuit board, and there is a digital control which is used to control all these components. Okay, so these are the various components of CMOS sensor. So let us discuss functioning of each component of this CMOS sensor one by one. So the first component that we have seen a color filter. Okay, so here you can observe the picture of the color filter, and here you can observe three types of colors: R, G, B. R means red, G means green, and B means blue. Okay, so different colors are formed by appropriate mixing of these RGB colors. Okay, so different intensities of RGB are used to produce different colors. Okay, so um, there are there is a array. There is a array just like pixels. There is a array of filter which is called as mosaic. Hmm? It is just like your tiles. How tiles are arranged in the same way, the filter of different colors, they are arranged in a matrix fashion. And here you can observe a basic or sub mosaic which consists of uh, 2 by 2 R, G, G and B. R means red, green, two greens are there and one blue is there. So this whole combination or cluster of these four squares forms what is called as a submosaic. Okay, and this submosaic is responsible for producing different colors. Okay, so each filter in a array corresponds to the pixel in a sensor. So here you can see how the filter is arranged. For each uh, sub mosaic, or for each square or each tile, there is a one pixel attached to it. So here you can observe here. Okay, so each filter in the array corresponds to the pixel sensor in the pixel array. And what it does is it only allows certain colors of light to pass through the pixel sensor. Okay, so the colors are filtered by this color filter and they are passed to the pixel sensor. Okay, so this is achieved by filtering out the other wavelengths. Okay, so if you are using red filter, other wavelengths are blocked and only red is allowed. If you are using green filter, only green light is allowed to pass through it. If you are using blue filter, only blue light is allowed to pass through. Okay, so by using different intensities of these red, green and blue, a particular color is formed. Okay, so this filtering is used to produce different colors. Now let us move to the next component of CMOS sensor, which is pixel array. Okay, the pixel array consists of millions of active pixels. Why it is called as active pixel? Because it comes along with the amplifier. It comes along with the amplifier, and therefore it is called as a active pixel, because amplifier is active device. Okay, so each pixel is a active pixel and it is responsible for capturing the intensity of filtered light. Okay, so light is filtered, it is given to the pixel sensor, and pixel sensor will convert it into electrical signal, or it will convert it into charge. Okay, so now this charge will be converted into voltage signal and it will be amplified. Okay, so with help of this amplifier, which is shown as a triangular shape, this triangular shape shows the symbol of amplifier. You have studied operational amplifier and its symbol is triangular. So this is amplifier which is present uh, immediate to the sensor. Okay, so sensor is connected to this amplifier, and this amplifier is responsible to convert the electron charge to the voltage. Okay, and at the same time it is going to amplify, or it is going to enhance its strength. Okay, so here the voltage is available. Okay, now each individual pixel sensor converts the intensity level into a voltage signal before passing it down to another part of chip, such as analog to digital converter. So here the difference lies between CCD and CMOS. In case of CCD, the charge is passed, but in this case, voltage is passed. Okay, so this is what is happening here. So now you can see here there is presence of horizontal shift resistor, there is presence of vertical shift resistor, and one by using rows and columns, the voltage is applied to the horizontal shift resistor, and through horizontal shift resistor it is given to the analog to digital converter to immediately convert the signal into its corresponding digital value. Okay, so this is what is the function of the pixel array. Now let us come to digital control. The digital controller is a set of circuitry which is integrated into CMOS sensor. It is within the CMOS center and it controls the pixel array, because there must be a clock generator or oscillator within itself to shift the different voltages horizontally and vertically, and whole this process must happen in synchronization with each other. So for this purpose, clock generator is required and a circuit is required to control its motion, okay, in vertical direction as well as in horizontal direction. So these two functions are carried out by a digital control, okay. So digital control is also responsible for telling the pixel array to when to start capturing light, okay, and when to shift the charge, etc. So all these functions are carried out by the digital controller, which is integrated into image sensor. So as I told you while studying the pixel array, we have seen that analog to digital converter is also integrated into image sensor. So this analog to digital converter takes the analog voltage signal from pixel sensor array and converts it into digital signal. And the final digital signal is outputted to an image processor, because image processor is required in order to pass this signal to the device where it is required. Okay, so this image processor is another device, and this device is independent of CMOS sensor, and this image processor converts or processes the digital signal into something viewable by the end user. So image is made viewable with help of the image processor. Okay, so this is the intelligence which is added to the image sensor. Okay, so this is all about the working of the CMOS sensor. So let us discuss advantages and disadvantages of CMOS sensor technology. So its advantages are significantly lower energy consumption. So lower energy consumption means more battery, and you can use battery for long duration. So small camera size, as readout logic is integrated on the same chip, and speed of CMOS sensor technology is greater as compared to CCD, because in CCD there is a need to move the charges, but here directly voltages are shifted. So this is the difference which makes the CMOS sensor faster as compared to CCD. Okay, so flexible readout is there due to direct addressing of individual pixels, and due to direct addressing of individual pixels, the speed is increased. Okay, so the blooming effect which was present in CCD camera, or smearing effect which was present in a CCD camera due to motion of the charges, is reduced here because charge is not directly used. Okay, uh, but it lacks sensitivity as compared to CCD. It has higher sensitivity in near infrared region. Okay, so near infrared region it has highest sensitivity, so that you can use for night vision. Okay, so there are certain disadvantages, and one of the important disadvantage is that the greater sensitivity differences among the pixels, okay, due to production tolerance. So this is the big disadvantage, and this may lead to color noise. Okay, so both the disadvantages, they will contribute to less sensitivity of CMOS sensor. So less sensitivity is its disadvantage, but greater speed is its advantage. Okay, so today we have finished image sensors here. Do you have any doubt about image sensor? Yes, Molano, बोला
मॅम.
नाही. बर, आता we'll be moving to next type of sensor. Okay. Can you see the screen?
Yes, ma'am.
So what you can read? What you can read? Read the title.
Motion sensor or PIR sensor.
Motion sensor or PIR sensor. The meaning of PIR is passive infrared sensor. PIR is passive infrared sensor. Remember full form of PIR. Okay. So it is passive infrared sensor and it is used to detect the motion of the living thing. Movement of the living thing. Okay. So that can be detected by PIR sensor. Now, what is basic principle behind this is that every thing which is living has a temperature, certain temperature, and this temperature or thermal energy uh, emits radiation. Okay, and if you take example of human being are radiating at wavelength from 9 to 10 micrometers all the time of day due to heat in our body. Okay, so if we are capable of sensing this radiation coming out from human being, then we are capable of sensing the presence of human being. Okay, so this PIR sensor, it won't sense the static presence of human being, but it will sense the motion of human being. So this is important thing that you have to remember about the PIR sensor. Okay. So these PIR sensors, they are tuned to detect the infrared wavelengths. Generally, these wavelengths are infrared wavelengths, which are emitted by hot objects. Okay. Even animals, they emit heat and emit infrared waves. Okay. So even presence of animal also can be detected with the help of PIR sensor. And this can be tuned to detect the infrared wavelength when human beings arrives near to it. Okay. So what is passive infrared sensor? Passive infrared sensor is a sensor which is capable of detecting human being when human being is in range of its sight. ओके, म्हणजे त्याच्या दृष्टिक्षेपामध्ये जर मनुष्य असेल आणि तो मनुष्य मूव्ह होत असेल तरच तो सेन्सर काय करू शकतो, त्या ह्युमन बिईंगला डिटेक्ट करू शकतो. ओके, सो मोशन ऑफ ह्युमन बिईंग विल बी कन्वर्टेड इनटू an electrical signal by passive infrared sensor. Okay, so you can observe the actual image of sensor here. एवढा छोटा असतो तो, इतकी छोटा. Okay, now let us study elements of PIR sensor. So what are the different elements of PIR sensor that we are going to study? So here you can observe different components. So the first component here you can observe is a lens, and this lens is called as Fresnel's lens. Fresnel's lens. Okay. There is a filter. There is sensing element. Sensing element. So this is what is your sensing element. It consists of amplifier and comparator. Nowadays, all these things are integrated into a single sensor. Fresnel lens, filter, optical filter, sensing element, amplifier, and comparator. So all these are integrated into a single device.